Hello students, and welcome to this mini lesson on rotations and dilations. So this is really just an add-on to what we did last time with translations and reflections. So we're really not doing a full lesson here. Our objective is that we will perform rotations and dilations using journal notes and practice problems. So we've already talked about transformations, we've already talked about the pre-image and the image and what those are in relation to our transformations, and we've already talked about two of our major transformations in geometry. So now we're going to talk about rotations, and then we'll talk about dilations last. So rotations, we're going to talk about three different situations. So when we're thinking about rotations, remember that we're on a circle. And on this circle, if I'm at the center here, this is my kind of standard direction, right? Is that I'm going to be looking forward, or up in this case. And then our turns are going to cause changes, right? So if I'm going to turn this way by 90 degrees, then that's going to be a 90-degree turn. Additionally, I might also turn 90 degrees to the left. So we see that these are both 90-degree turns, so we need a way to distinguish them. Well, and that's where this comes into play. We have 90 degrees clockwise, or a right-hand turn, or I have 90 degrees counterclockwise. So now let's talk about some other turns on these clockwise rotations. So let's talk about a second clockwise rotation, and that's going to be if I want to turn around completely. And so I would call that a 180-degree turn. And there's one last thing that I want to talk about here. 180-degree turns we're pretty familiar with. We're familiar with 90 degrees clockwise. We're actually familiar with 90 degrees counterclockwise as well, but I want to point something out here, and that's that if I decide to go counterclockwise by 90 degrees, well, that's really just the same thing as if I were to go clockwise 270 degrees. And this makes sense because our entire circle is going to be made up of 360 degrees. So we have all these different turns, and I can see that I can actually describe all of my turns as a clockwise turn. And that's actually how we're going to describe things for the most part today. So all of our rotations that we're doing are going to be around my origin. So we're not going to talk about rotations around some point. We're just going to talk about the origin. Alright, so let's jump into each of these rules. So if I've got a 90-degree clockwise turn, then, well, let's just think about it, right? So I've got my ray here, and currently this point is at the points 2, 3, and 4, 3. And what we're going to do is we're going to execute a 90-degree turn. So we can kind of guesstimate that here. And what we see is that A prime is most likely going to be graphed at positive 3, negative 2. So we become A prime is going to be positive 3, negative 2 is A prime. And we see that B will become, if we do another little turn here, it looks like B will become positive 3, comma, negative 4. So what's the rule that we're seeing? Well, we see that if I rotate a point 90 degrees clockwise, then x, y will become y negative x. So that's our rule there for a 90 degrees clockwise turn. Alright, so this was a little bit of a tedious process, right? We had to kind of carefully measure out our angles here, and what we saw was that if we used a proper 90-degree angle, we could simply rotate them around the center, using it kind of like a circle. We don't need to show that for the rest of these, right? We've shown how that works, and now we can start using our intuition and our rules to guide us in the future. So I'm going to give you guys the rules instead. So for 180-degree turns, well, I'm going directly through, right? So I'm going all the way around, if I were to imagine that this is a circle that goes through that point, I'll go all the way around, and I'm going to follow this same vector length over here, and I get some point here. And then I'll do the same thing for B. So I'll get a nice little segment here, and this will be B prime, and this will be A prime. And notice that A prime is still closer to the origin than B prime. So that is appropriate for this. So what we see is that it becomes negative x, negative y. And we can show this using A prime. So we have our point 2, 3, and it is going to go to, well, my new A prime point became, this was A, and my A prime point became negative 2, negative 3. Alright, so and then for our last turn, let's go ahead and look at moving clockwise 270 degrees, or in other words, counterclockwise 90 degrees. So let's go ahead and see what the relationship will be. So we've got our vector here, right, that we're going to draw out here. And what I want to do is I want to rotate it by 90 degrees. So what I'll see is that I should get something like this. There's a nice 90-degree angle, and it looks like A prime is going to plot right here. And it looks like A prime's coordinates are going to be negative 3, positive 2. Or, in other words, I can say negative y, and then x. And so we can actually write out that proof. So those are your principal rules for when you are doing a rotation. You have your 90 degrees clockwise, 180 degrees clockwise, or 270 degrees clockwise, which 270 degrees clockwise is just 90 degrees counterclockwise. Alright, finally we need to talk about a dilation, or also known as a resize, and this is going to be the strangest transformation for you guys. So when we're talking about a dilation is when you take a figure and you either expand or compress it with respect to a fixed point. So it's kind of like a projector, right? You're looking at a projector screen, and then depending on whether or not you put your your whiteboard closer or further from the projector will decide how large the image appears. It's the very same thing happening here. We're talking about a dilation in respect to some fixed point, and in our case that'll be the origin. So when we describe a dilation, we're going to talk about a preimage of xy going to some image which will be k times x and k times y, where k is something called the scale factor. Alright, so given the points A, B, C, I want to dilate these figures by a scale factor of 2. So if my k is equal to 2, then I'm just going to apply the scale factor to each of the points. So I have 2 times negative 2, which will give me negative 4, and then I have 1 multiplied by 2, and that'll give me 2. So A prime is going to be 4, negative 4, 2. So I go to negative 4, 1, 2, 3, 4, 1, 2. And so that'll be my A prime. So B is at the origin, and remember these dilations expand or compress with respect to a given point. So we're talking about how far are you away from the origin when this transformation occurs. And because B is the origin, it isn't going to move at all. So 2 times 0 is still 0. And then 2 times 0 is still 0. So we've got B prime is still at 0, 0. And then finally we have C. And so C is at negative 2 currently. But when we multiply it, it'll be at negative 4, negative 4. So then C prime is at negative 4, negative 4. So if we connect these, what we see is that it's a very similar shape. And what we see is that a dilation of a figure is going to continue to be the exact same as far as the shape. So we can say that dilated images are the same shape as the preimage, or we can also call them similar figures. So, like we've said before, you can perform multiple transformations in the order that they are given. So make sure that you're following the order of those transformations as they are given to you. So your reflection today is that you're going to take this preimage, cat, and what I want you to do is I want you to translate the preimage by 5, -2. And then I want you to reflect the preimage across the x-axis. When you're done, go ahead and work on the finished translation, reflection, dilation, and rotation practices. I hope you guys have a wonderful day, and let me know if you have any questions. Goodbye.